been the Play Store, for example. It was called Android Market. And the very early Android Market app was really bad at reporting updates. So you have a ton of apps installed on your phone, and there were updates available for it. And nowadays, the Play Store just says you, hey, there are free new updates for your apps. So the Android Market app, most of the time, it did it too late, and sometimes you didn't get a notification at all. So that was problematic. So I thought, well, there has to be a solution for it. And I did some research, and there was an unofficial Android Market API where you could get information about apps, like how they are in the Android Market right now. So I used that API to create an app that would check for your installed apps periodically, check for newer versions available in the Android Market, and generate notifications for you. That was basically the app. It was quite popular. And yeah, you see, these are just the plus runs and ratings on G+ here. And I created a free version with ads in it, so to create some revenue, of course. And back in the days, there were no in-app purchases like nowadays. So what you normally did, you had a free version of your app with ads in it, and you had another version, like a pro or premium version, which didn't have ads and maybe some additional features or something, and you put it in parallel in the market, like for €1. And that's what I did. Yeah. So basically, I will have one slide with a graphic on it, and I will tell you much about it. Then I will just skip the text slide, because later I will share all the slides, and you can read all the stuff that I just said on the text slide. So some statistics on the app. I had, like, for the premium version, a specific amount of downloads that obviously I could have a look at in the Android Market console easily and see that I had X installs that people purchased for money over the Android Market. And then one day I realized that I hadn't included analytics in the premium app. So I included analytics, and I saw that I had 20 times the number of active users that had purchased the app in the Android Market. So it was like 700 versus 14,000. Yeah, that's a problem. So what kind of problems do we face if we have a situation like this? I'm going to show you just some of the problems that will be created out of such a situation. So obviously, we will lose money. So for every pirated copy of that app, I didn't earn that €1 that I had put it in the Android Market for. So what I earned was €700, but I had to provide the app and the service for 14,000 users. And of course, if it would be an app that also had ad revenue in it, or ads in it, you would also lose the revenue. Or if it has additional in-app purchases, you earn no money from the in-app purchases. Next, we have orphaned apps. The problem is, once your app gets pirated and it gets redistributed on some third-party marketplace or whatever, you basically lose control over the app. So imagine you have an awesome app that is functioning perfectly, and then someday you realize there is a major bug in it, like it crashes at some point because something else in the Android system changed or whatever. It doesn't run good with specific Android versions that are new or something like that. With the app that is in the Android Market, you can just publish an update and then the users are fine. The app doesn't crash anymore. But when the user installed the app from a third-party source and didn't pay for it, you won't be able to provide updates for them. They're just stuck with the version that they downloaded. You have no control whatsoever. So, next issue. It's called ad ID replacement. So imagine you have a free app that you want to earn money via ads. So you design your UI, which has an ad banner on top, and you do that by simply adding the ad in your visual layout of the Android app. So you normally use an ad network like AdMob. AdMob is the most popular one. So you register an AdMob account, you say, I create an app, and you get an ID for that app. so that you can place ads in your app, and AdMob can map requests and clicks on those ads to you, so that you earn money from it. So what pirates do is they simply grab your APK from the Android market, and this is just a UI layout in Android written in XML, and at some point you have an ad view in it from AdMob. And a parameter of that ad view is, of course, the ad unit ID. So what they do is they erase your ad unit ID, register an AdMob account with an app on it, put their own ad ID in it, and they redistribute the APK. So people who download the pirated version of your app get the exact same app. There are no differences, except for when they click on an ad. It's not you who get the money, but it's the pirate. Yeah. Next, unknown modifications. The process of pirating an app, if it's not just copy-paste, involves some decompiling, maybe editing stuff, repackaging it, resigning it, and all of this can introduce bugs, for example, that you cannot control, and the user cannot know who introduced the bug or who is responsible for the bugs. That's also an issue. Next is malware. When you download an app from a third-party place, most third-party market stores don't have signature checks or anything like the Play Store does. In the Play Store, only the developer who has the private key for signing an app can upload a new version of the same app. So you can always be sure that when you download from the Play Store, it is from the developer. It cannot be from somebody else. But once you install IPKs directly, you have no control of checking who created the APK, or if it was altered in some way, or if it was malware that was added. So in most cases, you will just get the exact same app that would normally cost like, I don't know, €5 in the Play Store. You get it for free, and it does all the features that the normal app does. And for you, it looks like the very same app, but maybe in the background it grabs all your contacts and sends it to a server, or it reads all your SMS or whatever. So yeah, that's a problem. Next problem is unpredicted traffic. So take my example of app update notifier. As I said, I was using the unofficial Android Market API, which of course did some server requests, some API requests. I didn't want to hammer the Android market with requests over and over, so I implemented some caching on my own server. And normally, like, you have to pay for traffic, right, on a server. And now imagine that I had a business plan calculated for my app update notifier app, which was calculating for like 700 users like I had from the Play Store. So I calculated traffic for 700 users. But then again, analytics showed that I had 14,000 users, so 20 times that amount. And those users created traffic on my server. So if I wouldn't have a flat rate on my server for traffic, yeah, I would have to pay for those pirated copies and for those users that use the pirated copies that create traffic on my server. Also, yeah, as I said, the process of pirating can introduce new bugs. Just by decompiling and resigning, you alter the code somehow, and it can introduce new bugs. Of course, another problem is just copy depths. It's really easy to just, even if you have a rooted phone, it's even easier. You can just copy paste the APK to whatever folder you want, and another device has the same APK. There is one library from Google that can prevent such things. It's called the license verification library, and I will get into more detail on that library later. It basically communicates directly with the Play Store and checks when you start the app if you have really purchased on that Google account that is registered on your phone or tablet, if you have purchased via that Google account this specific app. Another problem is reverse engineering. Just imagine you have a really brilliant business idea, and the business idea is built on some magic algorithm that does some really cool stuff. And all of that magical, cool stuff is built in your app. So somebody just comes and grabs your installed your app from the Play Store, grabs the APK, and he can reverse engineer it or decompile it. And what he gets is basically your magic, cool Java code. And he can have a direct look at your super cool algorithm. And yeah, there goes your brilliant idea. Yeah. So a next problem is in-app purchases nowadays. Well, not nowadays, but it was for many years. Because imagine you have an in-app purchase for removing the ads in an app, for example. So the user purchases that in-app purchase, and you have to store somewhere that he made that in-app purchase, of course. So in order that you will be able to remove the ads, because he purchased the in-app purchase. So what you normally do is you just store it in some shared preferences or in some SQLite database or whatever. But yeah, you have to store it somewhere, and as well as APKs, Pirate can also simply copy an SQLite database or a shared preferences file. So yeah, he can also just copy your in-app purchases with the APK. So much for the problems. The next part of the talk is about how easy it really is to crack the apps. It's just to show you how really easy and fast it can be done. So we have to have a look at the workflow on grabbing an APK and decompiling it and recompiling it. So what we have is, we have an APK on the device and we need to download that APK, of course. Then next step is maybe we have to download some system resources for the framework to fill in some gaps that are in the APK. And once we have those two files, we can decompile everything. And what we get is resources, like images, XML, layouts, strings, everything. And we get code. And then we can edit that however we want. And once we're finished with, for example, add ID replacement, we need to rebuild everything into an APK again. But the user cannot install it yet because an APK has to be signed with a certificate. So once we are here, we have an APK ready that may be not the same as that one that we originally downloaded because we made some modifications, and people can install it again. So what tools can we use to accomplish this process? The most common tool is APK tool. APK tool has two main functions. It's decode and it is build. So decode is the decompiling step. It will take your APK and generate the resources and the code and everything. And build will put all those stuff and generate an APK again. So I did it for an example APK, base APK that I grabbed from my device. And what you get is an output folder with all the stuff in it. Then I made some modifications in the correct folder and repackaged everything with called correct APK, and then you have to align and sign it, and there we go. This is the edited APK, approximately the same size, with my modifications. So the kind of code you get from the decompiling step is not really well readable, let's put it that way. But there is a tool that can help you. It's called text2jar, and it will generate nice readable Java code for you. So for that Java code, there's an easy UI tool that you can just open the jar file and edit classes and everything. And if you want to have everything in one single IDE, you can also use Virtuous 10 Studio. And it's basically an IDE which incorporates all the other tools in itself, and it provides you with one simple workflow to decompile an app and generate Java code from it. Okay, how does it all fit into our process? We have the download APK step. Yeah, we can use the Android debugging bridge. You know the Android debugging bridge? It's just the thing that when you hit launch on Android Studio, it uploads your APK, for example, and starts it. So you can also use a pull command to just pull files from your device to your hard drive. There we go. Next, we need to decompile stuff. APK tool. Now we need to edit our resources. And we can use whatever image editor, XML editor. What is your preferred editor? Then we apply dex2jar to the decompiled code. And we get nice Java code, which we can edit with whatever we want, like IntelliJ, or some might be using Eclipse or whatever. And once we're done with editing, we need to rebuild everything. Yep, APK tool again. And when we have the rebuild APK, we need to sign and align everything. And here comes some standard JDK tools. It's basically in Android Studio, if you hit the run button, the Gradle does everything for you, calling these tools, but you can also do it manually. It's very well documented on the developer.android.com website. Okay, so I prepared some examples of how to do that. So I said, like, it's really simple to copy stuff. It's just like one command line. You know the copy command from Unix. And you just have to know the package name of the app that you want to copy. And then there is the base APK file in it. And that is the app, basically. And you just copy it to, for example, your SD card. And there you go. You can share it to wherever you want, like Dropbox, torrent servers. You can copy it to other devices, send them to friends, upload it to third-party marketplaces, whatever. It's just one line of code. Or it's not even code, it's just a command. What about expansion files, or SQLite databases, or shared preferences that store your in-app purchases? Yeah, it's all under this folder here. You can copy everything, even especially if you're rooted, you can really copy everything. Okay. So I said that the code you will get from decompiling is somehow complicated. It's called Smali code. So let's have a look at it. I have created a sample application, which is on the GitHub also. And what it has, it just had one button called check for license, I think. And it has a text label which says premium license or free license. So on click of that button, I call a function called perform check for pro. And of course, I want to return false in my free version, so that the app thinks it's a free version, not a premium one. So this is some kind of assembler-like code that you get, which the Java virtual machine, Dalvik, will understand. And I want to return false, which is 0, obviously. So an attacker that wants to unlock your free app and convert it to a premium app will return true from that function, obviously. So he just takes that 0 and replaces it with a 1. And that's it. Recompiling, rebuilding everything with APK tool, and there you go, you have the premium app. Just a 0 to a 1, that's it. Okay, add ID replacement. This is some output from APK tool, as you can see. And it, for example, it converts your XML resource files, which is this one here. And it will give you an add unit ID in your add view. You just replace this string here, and there you go. Rebuild everything. You have your APK with your own add ID in it. Okay, so it's really easy. And now comes the last important part of my talk, which is what can we do to make it harder to crack the apps? Hopefully more than that. Okay, so this will be the reaction of a pirate when it sees that you are using ProGuard on your app. So ProGuard is a tool that helps you make it more difficult to see what your app is actually doing in the background. Normally it's just there for optimizing stuff and yeah, optimizing some things, but one of the benefits is that it does obfuscation also. So normally you have your Java source code. And then there comes the Java compiler, which converts it to some bytecode, Java bytecode. And then there comes a tool called DEX, which converts the Java bytecode to Dalvik bytecode. And here comes ProGuard into the game. ProGuard takes your Java bytecode and applies some optimizations to it. One of the optimizations is obfuscation, if you enable it. And you get an optimized bytecode, which is far more difficult to understand. And why is it more difficult to understand? Well, here is why. I had my main activity class, and I had a text view in it, which was called status text view, and I had one function in it called perform check for pro. Pretty easy to find out which function you need to crack in order to unlock the premium version, right? So what does ProGuard do? It renames, for example, all of my fields to A, B, C, AA, whatever, some meaningless stuff. And it does the same with functions. Now the function is just called A. In this example, it's really easy to find the function that you need to crack in order to unlock the premium version because there's only one function. But imagine you have a larger file, a larger class with 100 functions. Well, and if they are named A, A1, AB, AC, it's really difficult to find the correct one to crack. So another thing is server-side security. Like I said, you might have that really, really nice algorithm, for example, and if you put it in your app, it can be easily reverse engineered. But if you put it on your server, for example, and the server is behind a firewall and you can only get to your magic algorithm via an API, yeah, the user can crack your app however he wants. He won't get to your magic algorithm because it's stored on the server. Obviously, make use of HTTPS encryption on your APIs, because otherwise people can just read what you send and what you receive, which might be a problem. And next is the license verification library. So yeah, it's basically this guy, which means it's the Play Store, checking if you have a valid license to run the app. And how to use it, it's pretty simple. You just include a library from Google, and it has a license checker on it. And you have to do some initializing, it's pretty easy, and then you call check access and provide a callback. And that callback is really pretty easy. It has a function called allow. If it checks and it gets back that it's a valid license. So allow the user to use your app. And it has don't allow, which also has a reason to say why it thinks that the user hasn't purchased the app. And of course, there can be an error. So pretty easy to include, and it communicates with the Play Store directly to check if the user with that Google account that is registered on the device has purchased the app that you want to run. Next, and maybe the most powerful, is service-managed accounts. Just think about Netflix, for example. Netflix manages their accounts on their servers. So when you want to use Netflix, you have to subscribe to Netflix. You have to have a subscription. And that subscription is managed on their servers. So once you pay, they throw on the servers. Yeah, the user has paid for 1 month, unlock the stuff. From the Android app perspective, you just have an API to interact with the servers. So whenever you request a video, you want to watch a video on Netflix, you make an API request to the server, and the server checks for your subscription. And when you have a valid subscription, you will get back the video. If not, you will get back an error. So a pirate can come and crack your Android app however he wants. He won't have a chance to get your video data without you allowing it on the API side. In-app purchases. I have already described that it was a problem for many years. Well, it's not anymore. You don't have to store in-app purchases anymore, because with the latest Android billing API, it stores everything for you in the Play Store. And you mainly interact with the Play Store indirectly via that billing API. And it already includes stuff like caching and offline access. And what you do now is you don't store that he has unlocked the remove ads in-app purchase, but you just ask for it on every start of the app. and the billing API will tell you, yeah, he has purchased the stuff or not. So storing all the in-app purchases is not your responsibility anymore, but it's the responsibility of the Play Store app. So there is no possibility to just simply copy a file and you get all the in-app purchases. That's the benefit from it. Okay, I have collected all the resources for you. When you check the slides, you will have all the links in it for text to jar, the code conversion stuff, the decompiling stuff. The manual signing is described on developer.android.com. You also have ProGuard, which is already included in the SDK. You don't need to do anything in order to use it. You have the nice jar editor and the Virtuos 10 Studio. And yeah, as I said, every piece of code that you have seen here is on the Piracy repository on my GitHub account. I have also committed the decompiled files and the edited files and the recompiled files, so you can have a look at every step that I did during the creation of the example project. Yeah, now we have time for questions, and if you feel like, you feel free to provide me some feedback. Yes, questions, please.
Is there any way to handle the reverse engineering issue? Maybe, for instance, I can send a report to a committee, and if the committee reviews my request and gives some information about the apps.
You mean if you can prevent people from reverse engineering your APK? You mean if you can prevent people from reverse engineering and having a look at your code? Basically, it's stuff like ProGuard that you can apply that makes it more difficult to read the code that you decompile, but you cannot forbid to decompile an APK. Yeah, it's just possible by definition.
Only stole the idea, just the idea, not the code.
Store the what?
I mean, someone just get my app.
Yes.
Just steal my idea.
Your package name, you mean?
No, the algorithm, the UI.
Yeah. Okay. Yeah, he steals your algorithm, yeah. And then yeah, he can use it in his own app, for example, yeah. Or build his own app around it. Well, yeah, basically you can't prevent it. He can just decompile your app and have a look at the code. There's no possibility to prevent it. Yeah, unfortunately. You can just make it more difficult to read the decompiled code.
Maybe some authorities establish a committee to review this requests.
It is possible, of course, if you see that somebody else has copied your algorithm and uses it in your own app, you can write to the Play Store and say, hey, this was my code. And maybe they will react, maybe not. But yeah, you can do some steps against it, of course. Yes. Yes, please, we start here.
Okay, so I have two questions. First of them is, does ProGuard encrypt resources like images and XML files, or are they plain text?
They are plain text. And there is the guy who created ProGuard mostly created also a company after it was so successful, and Google used it for Android development stuff. And he created a project called DexGuard, which is basically the enterprise version of ProGuard, which encrypts strings also.
So I have another question. I saw a complex guarding mechanism that takes your application and packages it with another application, then encrypts your application. And when you run that application on a user's mobile phone, it decrypts your application in runtime and then runs it.
Yeah.
Do you know about that?
Yes, there are also many other tools. ProGuard is just the most basic one. The thing is, with all these more complex tools, they add more complexity to the reverse engineering step. But of course, you can, if you know that it uses this tool, for example, you can also reverse all the steps that it does, or yeah, grab at runtime the code that you originally wanted to have or something. It just adds one more level of complexity to crack your app. But yeah, there are more tools than I have here that help you to make it more difficult to get your original code back from the APK. Yes. Yes.
Can Pirate crack my app even though I used ProGuard? Or it's completely impossible for now?
No, it's actually quite easy.
It's easy?
Yes. As you saw, ProGuard mostly does some optimizations and that obfuscation stuff, for example. Sorry?
So we can just use ProGuard for securing our app from pirating. We have to use several tools.
Yes, again, it's some kind of process of thinking how much does an attacker want to pirate your app, how much time does he want to invest to crack your app, and how much time can you invest to make it more difficult. So you can add ProGuard, you can add DexGuard, you can do other tools, and all of these tools add one more level of complexity to get your original code back. And maybe at some point an attacker thinks, yeah, if it takes me like 5 hours to crack the app, forget it, I just purchase it for €1. So yeah, it's a process of finding the sweet spot where it becomes more difficult to crack it than the benefit than he has from cracking it. But yeah, simply using ProGuard, it's pretty easy to crack the app. Please, you are the next.
We are using some kind of authorities, for example, for content provider in Android applications, and these are literal strings. When we were using this, we are just giving the authority and saying that, yes, insert this content provider. But after presentation and for example, it was, I guess it's very easy to get this fully qualified strings and everything, so that
yes.
Can just insert or alter every kind of data.
Yes, also it's a similar thing with APIs that give you an app ID and a secret hash, for example. Yeah, if you store the secret hash in your strings XML, people can just grab your secret hash and access your API. Yeah, it's basically a flaw with how API authentication works nowadays. For example, you can use DexGuard, which encrypts strings also. That makes it more difficult, and the secret is not clearly readable, for example. But yes, it's really difficult also when storing encryption keys or decryption keys. I once did an app called Cheating Birds. It was basically a level unlocker for Angry Birds, because Angry Birds stored everything in just a simple JSON file that was publicly writable for every other app. So you could just edit it and levels were unlocked. And then with Angry Birds Rio, it didn't work anymore. So I checked it out, and yeah, the JSON file was encrypted with AES. So yeah, I started debugging stuff, and oh, they are using the NDK. Which is not a problem. There's also a debugger for native code called GDB, the GNU debugger. Yeah, so you can also set breakpoints and everything, and I was just setting a breakpoint at the AES decryption method, and there was the key in memory. So yeah, Cheating Birds Rio was born. So yeah, not even native code. It's just one more level of complexity, which makes it more harder to crack the app, but it's not impossible. Okay.
So you talked about some ways to prevent hacking and pirating applications, but there are still some very high budget companies which produce high budget games and applications, but they still got pirated pretty quickly. So yes. Ultimately, can we say there is no prevention to piracy?
Yes, there are just ways to make it more difficult. And there were maybe one, because you won't find any cracked apps for Netflix. So service-managed accounts are a way to prevent piracy.
Then can we say, is it wise to invest in security for applications if they are pirated very quickly? Or can we just write plain code and not encrypt it and don't invest in it because it's going to get pirated?
Yeah, so I would say if you have the time, do it, because it will prevent script kiddies from just decompiling your app and doing whatever they want, because it's a bit more difficult. But yeah, you have to find the spot where it becomes more costly for you to implement anti-piracy mechanisms than it is that the pirated apps give you. Like, for example, if you have a game that doesn't create any bad stuff for you, if it gets cracked, like for my app, it created traffic on my server, but a simple crack which works offline, a simple game which works offline, doesn't do me any harm, really. I doesn't earn any money, but it doesn't cost me any money if it gets pirated. So I wouldn't invest that much in anti-piracy stuff for that game as I did with App Update Notifier, for example. Yeah. Yes, please.
How safe are the PAM certificates?
The what?
PAM.
Certificates for signing the stuff. Yeah, it's pretty safe. So you can be sure if you download an APK from the Play Store verifies that it is signed with your developer certificate, and nobody else can upload an APK for your app on the Play Store. Yeah, it's pretty safe.
But, there is a PAM certificate for API and application conversation that encodes the request I send and response coming because on both server side and application side. But it must be downloaded to application, or it must be in application's build folder.
I see. So
how safe is it to keep it there, or is it the same as downloading the zip file and get the certificate, or just put it in the app?
Yeah, this is basically the benefit of public key signing stuff. You can encrypt stuff and you can sign stuff with it. And the benefit is that you don't have to give out your private key to people in order to verify that you created the data that they are receiving. That is the benefit of that mechanism. So you won't have to pack your private key, your password basically, in your app. That's the benefit from it. So yeah, it's pretty safe, yes. Yes.
It's somewhat related to the other question. So you said that PAM certificates was reliable and secure. So if you think about it, if you do a man-in-the-middle attack and make yourself a Google server, and you only need to install a certificate on the client's mobile, right? Then you can install any app you want as any developer.
Yeah, not that easily, because basically the process of verifying the stuff is when the developer uploads a new APK to the Play Store. So you would have to go in between the developer and the Play Store uploading the APK. So
when the user is downloading the APK, if you man-in-the-middle attack the process of downloading the APK.
I see, and you fake to be the Play Store.
Yeah.
Yes, I see.
And root certificate installed in the mobile.
Yes, that might be possible. Yes. Also, if you are using your own certificate stuff to interact with an APK, of course, you have to make sure that your key size is long enough and stuff like that, because short keys can be cracked easily and everything like that. Yeah, so yeah, that might be possible, yes. More questions? No more questions? Okay, then I'm out. Thank you.